All right, our last speaker for today is Mr. David Jones. He asked that I condense his bio a little bit, so that's what I'm going to do.
You can stop now.
David is the GIS program lead for U.S. Forest, NC Forest Service, and today he's going to be talking about the Southern Forest Area Change Tools Project. Well,
Thanks, man. I've got too many passwords to want to roll off of that computer, so give me just a second. Of course, I'm going to try to do live demos, so everything will break. All right. Well, I know some folks in the audience are aware of this project already. I think it's been presented in one form or another at two other state GIS conferences. But probably the biggest difference is we're going to be changing the name this year. This project was called the Landsat Forest Area Change Tools Project because we were using only Landsat imagery, but this year we're going to be ingesting some other data to get at some of the products that we want to be able to produce. So a quick history on the project in general. In 2008, oh, thank you. Somebody speak up. Let's see here. You like that, huh? All right, all you missed was the cover slide. All right, so quick history. In 2008, the Farm Bill was passed, and it evolved a number of things, both in kind of agriculture sectors, but as well as in the forestry sector. It required that state forestry agencies working with the U.S. Forest Service, which of course we do that extensively anyways, but we're supposed to work with them to produce forest resource assessments and basically assessing the condition of forest resources in each of our states, and then identify issues that were affecting those resources and come up with strategies to address them. As that entire process was called the redesign of state and private forestry. So I know we've got at least one former U.S. Forest Service employee in here, so but probably everybody else. I don't know everyone else's faces, but does anybody know the three arms of the U.S. Forest Service? Okay, state and private forestry, research stations, right? You hear about all, we've got Southern Research Station in Asheville. We've got the National Forest System, right? So believe it or not, the U.S. Forest Service doesn't really work much at all on non-fed lands, right? So what do we have most of in the Southeast? Private lands. So forest lands are private lands. The point of contact for all those landowners, for all the forests, are the state forestry agencies, right? But we get some funding allocation to support programs at a local level from the U.S. Forest Service through the state and private forestry arm of their agency. All right, so they redesigned how we go about getting that money. And in order to get it, well, we get a base amount, but they took everything else and made it competitive. We had to get very serious about addressing the real issues with each of our annual proposals. And if we weren't clearly addressing something we found an issue in our forest action plan, chances are we weren't going to get any additional funding that year. So that was the whole point of doing the redesign process. And as a part of it, there was a focus on three themes. And these were national themes. So this is what people are doing. This is what our focus is on non-fed forest lands throughout the entire nation. To conserve working forest landscapes, to enhance public benefits from trees and forests, and to protect forests from harm. So all that said, it boils down to this simple statement. And it's not just southern forests, but they just happen to be the ones I care most about. There's a lot of things that are impacting the forests, and a lot of things that are happening that should happen, but it's just part of change, and we need to be tuned into what those changes are. So this is a pretty complex graphic that you can stare at for a while and start to wrap your head around it. But the gist of it is there's a lot of indirect and direct drivers that are causing that change. And one of the biggest things that all the states in the South recognized was that we knew too little about what the changes were, where they were, and when they were happening. So from that is where this project starts. So the take-home message really is this wordy take-home message. But the project is built to provide timely information that helps identify where changes in forests are happening. And if we don't have that, we can't implement A, effective programs, and be cost efficient in doing it, and we're not going to reach our short-term and long-term goals, right? So if we really just don't know what's going on with the forest, it impacts a lot of what our state agencies do on a day in and day out basis. So the initial phase of what was the Landsat Forest Area Change Tools project being rebranded to Southern or SouthFACT was designed to build web applications that support Timely. Timely is an important part of this piece because there are a lot of projects doing land cover mapping, doing change detection, but a good number of them aren't producing products at a within-year frequency. It's pretty rare to even get them on an annual basis, or if you get it at an annual basis, it's coming to a year or 2 years later. So we really wanted to have timely information about where these changes were occurring, the southern landscape. And the target of these changes really fall around these 5 bullets. So silviculture, so what are we doing when we're managing the forest? Where is all that management happening? Harvesting is just one example of management. Obviously we do a lot of other things and support landowners who are doing that. Wildland and prescribed fire, forest pests and non-native invasive plants, natural disasters of all kinds, whether it's hurricane, flood, tornado, wildfire is of course another form of natural disaster, and land use conversion. These are the biggest issues that we have when we're talking about losing our forests or needing to keep track of how they're changing and where they're changing. So this project is focused in the southeastern U.S. This is what's called the U.S. Forest Service Region 8. It includes 13 states. Technically it includes the Virgin Islands and Puerto Rico as well, but we're not currently including them in the analysis. They didn't express an interest, so there was no need to expand. And there's 142 World Reference System 2 tiles, and so each of these rectangles, almost squares, represent the area that a Landsat satellite will acquire an image. So there's 142 of those across these 13 states. So the satellite imagery that we're currently using is all right now from Landsat. Like I said, we're rebranding and going to be working on ingesting some other imagery here soon. But the ones with the green star are the ones that our code is currently configured to work with. We're not going back in time further than Landsat 5. We can talk about why later if y'all want. But one of the things that came up a lot when we were spinning this project up in its infancy was, well, what about, people were so burned on Landsat 7 having some no data. It has a malfunction on the sensor. It's essentially like the peripheral vision that helps it correct for the fact that it's going 17,000 miles an hour. It got stuck. There's no way to jump on board and fix it. So it is what it is. Yes, there are some no data areas in Landsat 7, but if you look at that a little closer, this is the scene on the right is the full size, the zoom in on the left. You can see these diagonal black lines. So that's basically where the sensor was not able to take an accurate reading of the surface of the Earth. If you crunch some numbers, and the squiggly lines are important, these are approximations, but they're not too far off. Total scene area over 7.8 million acres. If you're looking at that whole quad or whole WRS2, if you look at how much of that is disrupted by the scan line corrector issue, it's about 2.5%. If you were to combine two scenes, 2 different time periods, oftentimes they don't line up exactly the way the satellite took a picture the last time it was around out on Earth. So you'll get your lines. If this was a line one time, you might get that the next time. So if you combine them, you're looking at 9.2% of the scene is impacted by these no data areas. That still leaves over 7 million acres of unimpacted land, provided that you're not battling cloud cover in your analysis. So my answer to is it worth using is absolutely, because the benefit of using both the Landsat platforms in operation currently, 7 and now 8, is that we reduce that time resolution. We reduce the temporal resolution. They're on a 16-day return cycle, each of them, but offset by 8 days. So for me, knowing what the forest is doing today and knowing what it's doing in 8 days is better than knowing what it's doing in 16 days. So, and having a few blind spots. So I'd rather have the 8-day window option and have a few blind spots than always be stuck with 16 days. All right, so the analysis methods. Is this counting up or down? Down. All right. I might go over. Y'all didn't know what you're getting into. So the analysis methods, right now we're using three indices in one form or another. One, you've heard NDVI already used today, and Frank already prefaced the formula for us, so we're not going to go into that, but it's there on the screen. The normalized difference moisture index is also a fairly commonly used index, obviously not as much as NDVI, but it's fairly common. Shortwave infrared differencing, it's actually not an index because we're only going to use one band, and we're going to use that band with two time periods, and we're just going to subtract them. And you can express that in percent change, or you can just use the raw value of the subtraction. But all of our three products we do express as a percent change. So that fourth line there is just the basics of how you compute percent change between two time periods. So those are the three methods. We'll revisit those here shortly. Application design, I'm going to speed up a little bit so we get into the fun stuff. But it's entirely open source. All of our source code's on GitHub. If you go to our website, you can get direct links to that. So everything's in the public domain. There's no black box. There's no what did these guys do to get this project done. And it's entirely open source, so we don't have any money invested in software specifically. Obviously, we host our application in the Amazon cloud, so there's costs associated with that. But all right, so the web applications. Currently, we have three main features, and I'm going to go off of PowerPoint, and we're going to take a look at those live on the internet if my clicker will behave itself. So am I going to have to? Oh yeah. Wait, hang on a second. Duplicate. Keep them. Yeah, it's off. But you think it's still driving the slideshow aspect? I just tried to duplicate display. All right, well, this might get obnoxious. Here, I'm going to rotate around. As long as I can see what I'm clicking, we'll be all right. In theory. All right, this is going to be fun. You got that mobile mic? All right, so we're live. We're on the internet. This is like I said, currently we're still called the Landsat Forest Area Change Tools. Be changing soon. When that change happens, this domain will still be live. It'll just auto redirect. It'll give you a little cookie pop up says, just bleed on. It'll just be a little cookie pop up that says things have changed, and go check us out at the new place, but it's going to redirect you automatically, of course. Well, that's really loud. All right. So it's a website like so many. Some basic information on the submenu. If you want to know a little bit about the background of the project, technology that's being deployed, the project methods, the design, you can take a look at that stuff. Some user guides. So we've still got to develop this even further to be really useful to users. There is a desktop toolkit. It's not been pushed out to the web yet, but it exists, and if you're desperate to have it, just shoot me an email. We've got a page on project codes. You can get to everything that's on GitHub. Recently added some state and regional data, and we'll take a look at that in a minute, and some FAQs and a contact form if you want. So the three main applications right now are, as you see there, custom request. There's a notification system essentially, and a run-of-the-mill online web change, forest change viewer. So let's go into notifications first. We switched the order of the buttons based off of Google Analytics, a lot of people were submitting custom requests. We wanted to put it front and center for them on the left there. But managed notifications is actually going to change here pretty soon. Excuse me, I'm already signed in. If you want to get an account, you just hit register. Whirly bird. Fill out the form. There's nothing top secret here. We're not asking for social security number. Just need a name, an email address, and for you to classify yourself so we can kind of report back based off of our grant what our user group looks like. So the internet is going to be a kicker. So basic form, hit create account, you'll get a quick email and you're done. Let me go back into my, does that say demo at the end? Yeah. All right. All right, so I clicked on notifications, and right now we know this page is a little confusing, and we're going to try to be cleaning that up in the near future. We're splitting out how users will get to some of this information. Long and short, if you've created a notification, it's sitting here in this list of notifications. If you want to create one, you just hit create notification. You can name it whatever you want. You can select areas, and so what you're doing here is you're specifying a place somewhere in the southeastern U.S. that you want to know when we've crunched data and it's now available on the viewer, right? So what's going to happen here in the next month and a half is if you've given us an area of interest that's smaller, we're trying to find the sweet spot on size, it's probably around 50,000 acres, we will crunch change statistics on your area of interest and notify you if change was detected on the AOI. Right now your notification is saying, hey, there's some new data, come check it out in the viewer, and you'll get that in an email and the link will pass you straight to the viewer. But here pretty soon, if you give us an AOI, say you're a state agency, you got to monitor some conservation easements, you're worried about ATV, you're worried about timber trespass, somebody getting on your property, queue the property up as an area of interest, you're going to get an alert if something's going on. So right now you can select by county, you just select the state and then the county. Everything's in there in a drop down for you. We'll just, I guess we'll create one for Wake. Can't quite read, where am I, Wayne? And that, better hit clear or submit. Oh, okay, well, let me hit submit. All right, so if I hit submit, notification is in. So anytime there's new data for Wake County, I'm gonna get an email. It's that simple, all right? Like I said, again, if your area of interest is a little smaller, you're going to get an actual change notification if change is detected. So just to real quick show you, the draw area is just a typical little embedded map. We're working on enhancing the functionality of this a little bit, but it's not too hard to figure out. You just click around, and now I've got a notification somewhere around Aiken, right, South Carolina. You can also upload a zip shape. All right, so that's notification. If you've submitted a custom request, right now you're also going to see those data or those information down here in the custom request sections on your notification. This is the part we're going to split out. So there's going to be a custom request landing page for when you've got a bunch of those in the queue, and there's a notification landing page, and it'll be separate. But long story short, if you've submitted one, there is a status page, and let's just walk through. It looks an awful lot like creating a notification, but instead of a notification, we're actually submitting a request for something to be analyzed. So who knows if I can type. So I'll tell you what, what's the Alamance, right? By golly, I should be able to find that one in the list. Isn't it the first one? Yeah. All right, so Alamance County. All right, so this is us. This is me saying I want to do some forest change analysis in Alamance County. So in order to do that, in order to crunch change, we need 2 time periods, right? So I need to give the application a time period to establish a baseline, and I need to give it a time period that is whatever I want. Say I want it to be as current as possible. So another thing that you get into the weeds in the remote sensing world when you're doing change analysis. If you're going across season, what's going to happen, folks? Things change naturally across season, right? So if you compare in the dead of winter to the dead of summer, well, yeah, it's going to look like something's going on in some places. Some of that will be real, and some will, of course, just be an anomaly representing what naturally changes the vegetation. So you've got to stay heads up about that, and that's one of the outreach items that I think we can do a little better job on the internet. So let's just stay within the winter season, and let's say we want to compare 16 to 17 time frame. Fortunately, I didn't even realize this, but Wake County only intersects one WRS2. Right now, if you queue up an area of interest that is larger than 4, we're going to say, hang on a minute, we've got a lot of users to support. You could submit as many requests as you want. We're just not going to let you queue up the state of Texas all at one time. All right. So if you have an area of interest that intersects more than 4, you will get a splash screen that says you need to tone it back, make a smaller area of interest. All right. So you see your WRS2 is highlighted, and you basically have preview thumbnails. What are all those white things, right? Clouds. So do we want to run that? No. We want to go for something a little better. All right, what do we got? LC8, excellent. So we got a pretty clear Landsat 8 scene. It tells you cloud cover. I can't see from here, but there must be some wispy stuff on screen, maybe down in that area. But it tells you the date that was acquired was at 1/31. So let's see if we got anything. We've had some sunny days. Is that the 7? See if we get lucky. No, well we'll get anomaly there and some of the wispiness. Let's go back to the 7. Because we correct the surface reflectance, it doesn't matter that we're going cross-platform. There is some good literature out there now talking about comparing 7 to 8. But when you're looking for dramatic change, I mean, if you're trying to do something really sciencey, like map, cover, or look at phenology, or the start or the stop of the growing season, yeah, you don't want to necessarily be going cross-platform because the sensors are a little different on those two platforms. But if you're just trying to say, where is there something happening to the forest in a dramatic way or even a subtle way, but it's not, you don't need to go down the science pathway, you can go cross-platform, no problem. Going to surface reflectance changes the bit value, right? 8's a 16-bit image, so that's an issue if you want to just straight up do math. But once you convert to surface reflectance, that's not a problem. All right, so I've made my selection essentially here and here, and I hit submit. And it tells me your request has been submitted. You can go check out the status page, see what's going on, current request. It's currently processing, and I bet it'll be done before I finish my talk. So it is going to USGS Arrows servers. We've got machine-to-machine authorization for API downloads. We're not the only one, hundreds, thousands probably at this point, but they do require you to fill out justification to be able to programmatically download the imagery. So we've got that, and we're probably already in the process of physically downloading it to our server. So the analysis will be queued up here in just a matter of minutes. So that's the custom request, and let's look at the forest change view real quick. This is pretty run-of-the-mill web viewer. A lot of opportunities to improve, user interface and how the user gets to some of their data, making things a little less confusing, a little easier to work with, a little easier to interpret. One of the things we don't like about it is that we're just splashing you with all these colors right off the bat. So for a lot of users, they're staring at that and they're like, okay, now what? Well, the colors are pretty. What does that tell me, right? So what's queued up by default is the NDVI from our standard running product. And we really only have one standard running product. Aside from being able to serve up your custom requests once we've run them, there's only one thing that we're going to sit on and do routinely. And it's what we call the latest change product. And it represents the most recent possible change analysis that could be run for any area of the southeastern U.S. So if we get a clean L8 today and there's a clean L7 8 days ago, we're running it, right? So one of the benefits to this project that separates it from some of the other ones that are close to providing a similar service, they're not giving us that early warning, that early detect, and they're certainly not giving it to us. The next best thing is another application the U.S. Forest Service has, and it uses MODIS data, so it's a lot coarser spatial resolution. You can't find disturbances on the landscape. By the time they turn their forest mask on, most of what you're trying to see is not even on your map because they don't even have a good forest cover layer. It's great for big stuff. If the tornado went across the state of Alabama, it's going to show up on MODIS quite nicely. If a guy cut 3 acres in the back of his farm, might not show up on MODIS, but it's going to show up here. So by default, you have NDVI on. That's the latest change. You can turn on whichever you want. This SWIR product is probably the best for really cleaning things up. A lot of the speckles you see up there are clouds or remember those scan line corrector errors, so that we call the gap. So it's because it's a gap in data. So we're getting ready to back populate our archive because there were some issues with our rasters, which is why you just saw everything disappear. But that'll be fixed here really soon, probably before Wednesday. Dave, a colleague of mine, will have that addressed. But so instead of going down through the latest change, because actually that particular one is working off of Mosaic, and the Mosaic stitcher we took down. So one of the challenges to working with USGS is there are entire groups within the federal. Yeah, I'm out of time. How long has that been zero? All right. Well, y'all can get up and leave whenever you want. I'll just keep talking. All right, so there's entire groups within USGS that are doing similar projects and at times aren't even aware of the other group within the own organization. So it's a real challenge when you're trying to build an application that provides a service that's not existing, and you're trying to make sure that you're not duplicating someone's efforts, because you can't call up one person and say, hey, what are y'all up to? Because they honestly don't know. They know what they're up to, but they don't know what the other group is up to that's literally down the hall or just across the way. So that's a little frustrating. One of the things they did this year, which isn't necessarily a bad thing, it's just a curveball, is they changed their application programming interface from a SOAP API, that's just programming jargon, to a JavaScript. So everything we were doing to download imagery had to change. And they're not documenting their API exceptionally well. So when you look for what a function in programming is expecting to be passed as a parameter, they don't have their functions defined any place in the documentation. Or it's dated. So you build it the way the documentation says you to, and it's continually breaking. You're like, I don't know what's going on here. And then eventually you figure out, oh, well, it was expecting something else, but the documentation doesn't help you with that. So that's been a real pain to deal with this year, and it's impacted some of our latest change. But the custom request stuff is still there, and I did queue up. Let me figure out my numbers real quick. That's one thing we can work on, is how users get back to it. You can view all your custom requests here in the viewer. I didn't mean to do that. I meant to do that. Still processing that one. Which one did I do? Did I do a Raleigh one? Yeah. What does that say? 670? All right. So run 670 sitting down here in Landsat demo. It's right there. So if I turn that on, I'm going to go back up and turn off the latest change just so it's out of my hair. So I did a little run for Raleigh. Don't think I put it in there. What we got? We got, read those dates. Whatever those two dates are. That's what your change analysis was. All right. So it was a pretty tight window, right? I did it like this year, right? All right. So it was what? January, February this year. So pretty sweet. All right. So the new stuff, the masking behaves itself. So we just saw a lot of that clutter get gone. There's some of the cloud mask algorithm, you know, is not flawless. It's not perfect. It's not going to get every single cloud and every single cloud shadow. That's what we're seeing right here. We're seeing some clouds. So let me, this is going to be tough if I can't pay attention to where I'm at. There we go. All right. I want to say yeah, does anybody know what's going on at Lake Raleigh or Lake Benson?
Building a hotel.
All right, there you go, right there. There's your hotel.
That's a hotel and parking lot.
All right, so we're finding that changed pretty good. You want to do a little slider, you just grab the settings and get a little transparency going on and see what the dealie is. So I want to say, isn't it just north there, Centennial Way? I saw this earlier, that giant church. Isn't that it? Seems like it masked more than it should have. Yeah, that's not a legit mask. I think that's real stuff.
Is, we built the new facility.
Oh, there you go. There you go. Yeah, so that giant church is expanding. It got masked out, I guess, for some. Oh, no, the mask was just misbehaving. All right, so y'all know that church you can see off of by driving down Western, right? All right, so anyways, we're finding a lot of change. To give you an example, I do tree work on the side. I cut 7 trees down, 4 in the backyard, 3 in the front, a single pixel lit up. Okay, so, 30 by 30 meters, we're talking 0.22 acres. I've got almost an acre of land in southern Raleigh. If I mess around in the backyard, it's going to light up a pixel. So, yeah, can you map, classify your vegetation really well? Maybe not. Can you map the edge of water at the resolution that you want to? Probably not. Can you get a pixel to light up to tell you if there's something there for you to be paying attention? In most cases, you can. So, pretty slick. So that's the demo. Had to kill the PowerPoint. So, yeah, normally I do this in about 45 minutes. I was going to blast through faster, but I saw a lot of faces that I know are not aware of this project, so I took my time. All that was left in the PowerPoint was a little bit of what's coming in the future. Let's see if this thing wants to behave itself. Nope. What did we do before? All right, that was fun. When this presentation goes up online, you'll see a couple of neat examples. I've got some comparisons there to the U.S. Forest Service MODIS Space Viewer. It's kind of just interesting to explore how these two things behave. There are a lot of projects out there trying to map and monitor forest and other vegetation. Tons. They're not even all represented on this slide. And I find it extremely challenging to stay aware of all of these projects and to think about what are we doing that somebody may already be doing better and we should stop what we're doing or find something else. If it's not meeting the need, we'll focus on that and not focus on this thing that's already addressed. So I just challenge everyone to try to stay aware of these projects and make sure that if you're spinning up a vegetation classification project, a land cover classification, a change detection, or whatever, that you're thinking about whom else might be doing those projects and how y'all could leverage collectively your efforts. So that's just a snapshot of some of them. Our future plans, going to get some more information up on the website to make it easier for the users to know what they're doing. Like I said, area of interest forest change alerts. So if it's happening on the area of interest, pixel level change analysis level decisions. So right now, remember those big WRS2s. The best we can do is split the WRS2 into quarter quads essentially, and make a judgment about how much cloud cover is in each of those quarters. If each of those quarters is less than 50% cloud impacted, we'll run it with our latest change. But if it's more than 50%, that's just a lot of clouds, probably not worth it. Where we're headed is to make a decision about the pixels clarity, and if it's good, regardless of whether it's on a portion that's got a bunch of other clouds around it, we want to go ahead and make sure we detect that change if it's there and not cloud. So that's coming hopefully this year with the implementation of Google Earth Engine, which was a whole nother section of this talk. But there's honestly not more than 5 slides. Do y'all want me to keep going? Yes? All right, I'll keep going. I'll blast through. So Google Earth Engine is an amazing thing that Google has done. Right now it's entirely free. We heard at their summit last June, their current plan is not to start charging, and they're what they openly stated was that we're gonna, we're gonna play it by ear. If there's a commercial entity that starts wearing this thing out and they're making tons of money, well, yes, we need to make sure we recoup our costs. But as of right now, we want the public sector and academia to use this as much as they possibly can, and let's just explore the depths of what's possible. So what has Google done? They have ingested damn near every piece of imagery on the planet going back since we started doing it. And it is all sitting on their cloud in Iowa, wherever it is. I guess they got more than one of them. Don't we have one in the mountains like Lenore or something? I think there's a Google farm there. But long story short, they've got it all there, and they've built an application programming interface for you to programmatically interact with it. You can choose JavaScript or you can choose Python. Pick your poison. And you can hit that imagery without ever downloading it to your machine and analyze it in any which way just about that you want. Obviously, yes, you need to know how to write some code. And I think I've got that one up. This ain't going to take but a second. All right, so during the first talk of this session, I was really curious to see how well Google Earth Engine could do their 6 classes. So literally in the time that he was talking, I did a random forest classification on nape imagery in Wilson County, North Carolina. The 6 classes are color-coded about the way you would expect them. Impervious is, what is it, black? Oh, the points, well, actually, sorry, the points are black. The actual color on polygon is gray. And we're seeing it just about exactly what Frank was talking about with respect to teasing out vegetation. I think the forest cover just on this. So I have a Boolean version of Google Earth that's forest, non-forest. It performs exceptionally well. By the time you go to 6 classes, so how many points did I click? I just turned them off. It's not helpful. So I didn't do that much training, and it was really just, click, 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 casual, right? If I got a little serious about this, if I actually drew polygons improve performance over just a bunch of points. But long story short, here, let me hit run. All right, watch this little gray. Hello, Norman. All right, see the little gray below or in layers? So what is Google Earth Engine doing right now? It is running a very sophisticated, do y'all know what random forests are? Doesn't have anything to do with trees, actual trees. It has everything to do with decision trees and statistics. So random forest is a whole bunch of decision trees jammed together. It's doing a very sophisticated analysis and rendering it in a viewer dynamically on the fly. It didn't put that to a Google server anywhere. It's just doing it computationally and saying, here you go. If I were to do this on my desktop, I'd be at it all day, if not several days, just for this small little area. Is that sinking in at all? So let me give you another example. I'm not going to run this one because I did try it earlier and it would not go. But at my office, plugged in, I've got code to get a cloud-free, stitched-together pixel for a season from Landsat 8 for the whole nation, and it renders in under 10 seconds. Okay, it's going through a full season of available imagery and saying, okay, this is not a good pixel, that's a good one. This is not a good one, that's a good one. So it's doing all the cloud masking, it's making all those pixel decisions, and it's stitching all the pixels together into one image for me to look at. That is absurd. I mean, if you were to try to do that on a really robust local machine, you're talking months. I mean, you're talking UNC Charlotte or NC State's, giant warehouse computing lab, and it's still chewing. So if you're a programmer, go play with Google Earth Engine. It's free to sign up. You just got to fill out the little form and you're off to the races. So I'm almost done. Let's see if I can get this to behave itself again. So we are going to be migrating into Earth Engine this year, and our hope is that we can get to a user situation that looks something a little bit more like this. So instead of the users going through that application y'all just saw, they're going through something like this. They're telling us, hey, where are you interested in looking at something? All right, so not only does it actually establish the display extent to whatever we're going to show them in the viewer, that's also the analysis extent, right? Determine what time period you're interested in looking at. You want to crunch something from this week, this month. I mean, this is maybe too many buttons, frankly, right? We need to do some usability testing and drink the Asheville Kool-Aid and find out what the users really want to hear. But it'll be something like that, right? Determine which change products you want. Don't go into the detail of what an NDVI is or an NDMI is. I mean, people don't care about that. They want to know, are my trees dying? Are they getting cut? Is something bad happening to them? Is it really dry out there? Is there something really big going on that I'm not aware of because I live in Virginia and my property's in North Carolina? Or, you know, just throw it all on the map and I'll figure out what I'm looking at, right? And then lastly, there's gobs and gobs and gobs of data out there. GIS data already served up in various web service alternatives. So one downside of the modern day viewers you see now is they crunch all of them in there and somebody's looking at a layer stack in the table of contents. It's like 800 things long. You don't want to see all that. You don't want to have to whittle down through all that to figure out which one you want to turn on. We could dynamically pull those into the viewer. If you're interested in forest management, well, we'll give you all the forest management accomplishments that the states are queuing up and everything that's in the Fed system. If you're interested in forest fires, we'll give you all the VEERS and MODIS hotspot data that's already served up. We'll give you all the known fire polygons that are already served up in GeoMac and other places, right? So there's all these data. Forest health, similar, that's already in an enterprise system, storm damage, flooding, you name it. So the point of doing all that, this truly is the last slide aside from logos, is to try to have the trifecta, is what I like to call the trifecta of forest change. It's not just southern forest change, but obviously right now our project only exists in the forest. Phase 1 is funded, that's what I just demoed. Where on the landscape is change occurring? And let's get it as near real time as we can. Phase 2, what type of forest is changing? That's either going to be me wearing myself out and I don't get a PhD, or I get a PhD doing it. And phase 3 is not funded yet. We haven't submitted for it. But once we know where it's happening, we know what type of forest it's happening, we know what type of change it is, we've closed the loop. I mean, how many practical natural resource management and conservation related decisions can we make if we have all of that at our fingertips? Sky's the limit. Once we have it, let's do it through time. Done. Mic drop. All right. So there's partners, and there's us. Partners, lots of partners. So find us at landsatfact.com for now. You'll be redirected here pretty soon. Sorry I went over.
Anybody got any questions? So is any of this driving legislation or any of this being used in downtown Raleigh here? So I'm originally from California, and this is the type of stuff that 20 years ago would have been amazing. So there's like California Forest Resource Assessment Program.
Yep.
Is any of that being used here? Or who's really using it?
Well, so the city of Raleigh has a pretty robust urban tree program. You know, the city itself, I guess, technically does have quite a bit of green space. I don't know specifically if any city of Raleigh employees are aware or are currently using this application. They could. You know, I showcased a little bit of what Google Earth Engine can do. You know, so to get to that species piece, we got a lot of work to do. But part of it is getting a halfway decent tree canopy data set and then start interrogating spectral things within it, right? So we might be able to do that from NAPE. We might be able to do it from NAPE with Sentinel. We might be able to do it with NAPE, Sentinel, Landsat 8. Aster library is open and so forth. So where we're trying to get is to the level where you have resolution, you know, in very complex fragmented areas, right? So right now,
Is this driving policy as far as like timber harvest regulation?
there's no timber. The only state in the southeast that has a regulation related to timber harvesting is Virginia. They have a notification system where a logger has to notify them that they're going to cut timber. Everywhere else, well, in Kentucky, the forestry best management practices for water quality are mandatory. Nowhere else in the South are they mandatory, and frankly, they don't need to be because the voluntary program works outstanding. So, silviculture and ag have an exemption in the Clean Water Act, and there's good reason, although I work for the Department of Ag, so I shouldn't say anything about ag. Forestry, I think, does an outstanding job of protecting water quality as a whole. Do we have room for improvement? Absolutely. Are there bad actors? Absolutely. But are predominantly the folks cutting timber and paying attention to how they're doing it and protecting water quality? Yes, absolutely. So we're not using it to force legislation, but yes, the entire South is now using this application to stay heads up on where timber is being harvested, and they go out. Before I was a water quality before I was just GIS, and I used these methods before the application existed to find active logging jobs. I'd spend a half day in the office crunching Landsat imagery, and I'd have 300 plus logging jobs across a 20 county area, and I'd pop them all into my phone, and I'd go turn by turn directions to one another. And when I walk up there and I ask the logger, I'm like, hey, have you seen one of our county rangers yet? He's like, no, I haven't. You're the first guy I've seen out here. And, we just get to talking. He's like, well, how did you know I was here? Well, I found you from some satellites, And there's just like, they're trying to weigh you. They're like, is this guy, is he real? Is he joking? Is he pulling my leg? Right. So yes, you can actually use this to walk out on active, forestry. So it's not going to drive legislation, but I think over time, if we're monitoring the landscape at these resolutions, both spatial and temporal, then yeah, we could look at issues like, man, we're cutting ourselves out of an entire ecosystem in this area, or we're cutting ourselves out of a wood basket that we need, right? Everybody knows where tree hugger came from, right? Anybody? Did it come from somebody squatting in a sequoia tree in a redwood out west? No. It came from a forester wrapping a diameter tape around a tree, right? Same way the duck hunters save the ducks, the foresters are going to be the ones saving the trees, not the fools that think, they're wiping their rear end with something else. Don't shake their hand if they are. So I don't know if that really answered the question or beat around the bush. But
I was just wondering, because it's 20 years ago in California, this would have been an amazing product. It would have been used, it would have spurred some more arguments on this stuff.
You said 20 years ago?
Yeah.
Computationally, that would have been cutting edge. Some of the Landsat imagery was there, but physically crunching it the way we're doing now, that would have been cutting edge back then for sure.
No, so I was working in the redwoods 20 years ago, and the battles over the redwoods 20 years ago.
Yep.
This is absolutely amazing to see this technology.
I don't mind letting the cat out of the bag. The feds we write competitive grants to get this money. They have similar applications. They invest a lot of money. They invest a lot of money in a MODIS-based application. MODIS is about a decade past its life expectancy. The sensors are likely to go offline on their platforms. Literally, it could happen any day. Well, what's your backup plan? I want this to be their backup plan, and instead of granting us money for us to build it because it's a need, they just get it done. That's what I want my federal taxpayers' dollars for. Do it nationally. Be done with it. So.
Any more questions? All right, good job.
Thanks, guys.